Hello everybody, today we're going to be taking a look at inverse trigonometry. So using trig to find an angle, using those trig ratios we've been talking about to find a missing angle in the picture. And if you were in class, we started this little foldable here for inverse sine, inverse cosine, and inverse tangent. You can see that I have the symbolic notation for each of those underneath what they mean there in words. This idea of using an inverse is something that happens quite frequently when we're solving for x or an unknown. And that's exactly what's going to happen to us when we go about trying to solve for missing angles. We're going to need an inverse operation. So inside your foldable, if you open each one of those flaps, there's going to be a different picture. So let's start with the inverse sine. Go ahead and draw in this picture underneath your sine flap. And you'll see what's new in this picture right here is this. This is a 0 with a line drawn through it sideways or kind of diagonally. This is theta. Theta is a Greek letter that usually stands for angles when you're talking about math. So theta is just like an x. It's just like a y, an a, a b. We can solve for it. But theta is a missing angle in our picture this time. So rather than know that this is 38 degrees or 24 degrees, we don't know what the angle is, and we need to solve it to find out. So we can use inverse functions this way, or inverse sine, to help us figure this out. Here's how this would look. Let's pretend that we're still standing at the acute angle that's given. Well, it's not really given to us because we don't know how many degrees it is, but it is labeled with a theta. So let's pretend we are here. That's you. That's your smiley face, okay? And notice that the side across from me is labeled with 12, and the hypotenuse is labeled with 17. I have opposite and hypotenuse, so I'm going to go ahead and set up the sine ratio. It looks like this. Show this work in your foldable. Sine, and then after the word sine would be the angle. Now, since we don't exactly have a number of degrees here, we're just going to write in theta. So sine theta equals, and then let's go ahead and set up our fraction. Our fraction is opposite over hypotenuse, 12 over 17. Now, I'm trying to figure out what this is. It's just like an x. It's just like saying sine of x. I need to get that alone. I need to figure out what it is, what that angle is. How do I do that? Well, I can't divide by the word sine. Okay, that's a word. You don't divide by words. So here's what happens. This is when we introduce the idea of an inverse. An inverse will allow that theta to become alone. So basically, I take the sine inverse of both sides. And the sine and sine inverse will cancel each other out, leaving me with a theta. And over on this other side, I have to find the sine inverse, or the inverse sine, of 12 over 17. And I'm going to put parentheses around that because that's a fraction that I'm going to type in my calculator. So when I go to my calculator, this is the part that you want to type in. It says theta will equal, and we'll go ahead and type them in, sine -1, so sine inverse, inverse sine, you have to hit a second button usually to get that, and then 12 divided by 17, or 12 over 17, and it tells me that my theta is 44.9 degrees. Okay, so we're definitely going to need our calculator here to figure these out, and that inverse sine is just something that we do to both sides in order for my theta to be alone, okay, in order to isolate that variable. Let's try another one. This time we're going to set up the inverse cosine. So again, here's your picture, draw that one in there, and let's figure out where we're standing. There's a theta marked in this picture right here. That means here's where we need to be standing. That's the acute angle that's given to me. That's your smiley face again. And I see that I'm given the adjacent side, 32, and the hypotenuse is also given to me, is 35. So I know I'm going to set up a cosine fraction. So I'll do cosine theta, which we don't know. That's a number of degrees, some number of degrees, which we're going to find out. And then the adjacent over hypotenuse is what we set up for cosine. So 32 over 35. And now, just like the last one, we want to try to isolate this variable right here. He's just like an x, just like a y. So I need to do inverse cosine to both sides. So cosine inverse, cosine inverse. They will cancel, theta, cosine inverse of 32 over 35 is what I need to type in my calculator. And then I will go to my calculator to find out how many degrees my theta angle is. I will ask my calculator, again, it's not the regular cosine button, not the normal cosine, but cosine inverse, then 32 divided by 35. And your number of degrees should be, 23.9 approximately. So check your calculators and make sure you're getting something like that. I'll write it again because that's a little messy. 23.9 degrees is my missing theta angle, okay? So let's do one more. How about inverse tangent? So same idea. We know we're standing at the theta angle up here, and this is opposite, and 3 is adjacent, so we're going to set up the tangent fraction. Tangent of theta, unknown degrees I don't know, equals opposite 5 over adjacent 3. And then I will use inverse tangent this time. You kind of see what's happening? I'm just going to do the inverse tangent of that 5 over 3. So my theta is going to be whatever my calculator tells me when I do inverse tangent of 5 over 3. So theta is going to be, according to calculating device, 5 divided by 3 is 59.0 degrees. So knowing about inverse sine, cosine, and tangent will allow us to find missing angles that were not given inside triangles. Just like regular sine, cosine, tangent, trigonometry ratios allow us to find missing sides if we are given an angle. So they both have a place in finding missing pieces of right triangles that we're talking about. So what if you don't even have a picture? What if you have something like this? Sine B equals 0.4848. So how would we find out what angle we're talking about here? Well, think about what ratio must be set up. It looks like we have a sine, and we want to isolate that to find out what angle B is. So we're just going to do inverse sine on both sides. So B would become whatever my calculator says when I type in sine -1 or inverse sine of 0.4848. So instead of typing in a fraction here, we're just going to type in a decimal value. And in the same way, that calculator is going to be able to tell us what that angle is. 0.4848 inverse sine, that's approximately 29 degrees. Okay, and then let's do the same one with the cosine. Since the cosine ratio was what was set up here, was what the problem says, I will do inverse cosine to find the angle then. So angle A, however many degrees it could be, will be found by doing inverse cosine to the 0.6157. So inverse cosine 0.6157 is approximately 52 degrees. I'm rounding a little bit there. So A is approximately 52 degrees. So we need to understand both regular sine, cosine, and tangent ratios, as well as how to use that inverse when we're solving for our right triangles here. Okay, thank you for taking good notes.